system is they are the control system for your visceral organs. So somatic nervous system, which is the controlling of the skeletal muscle, we have learned with Dr. Jangunis. And those are under voluntary control. If you want to, raise your hand, and if you want to walk out of the room, and that's you made your conscious decision. But for the autonomic control, oftentimes this is involuntary. I wish I could stop sweating when I'm nervous. I wish I could, calm down and decrease my heart rate sometimes. But this is not really depends on your conscious, your conscious control. However, we do have like meditations that can possibly help us, which is not talked about until we talk about the brain control of your autonomic nervous system. Okay, so there's always exceptions. For example, in the somatic nervous system, the reflex arc is involuntary as well. Okay, so if we compare these two systems, one is voluntary, one is involuntary. Although we do receive sensory information from the internal organs and the glands, that those are controlled by the autonomic nervous system, we only refer to the motor control part of the system as the autonomic nervous system. We don't really talk about the sensory neurons involved in this pathway. Okay, so they are the visceral motor neurons. Visceral means internal organs. So the targeted organs for this system, including cardiac muscles, including smooth muscles that, for example, your blood vessels, including other internal organs like your GI tract, the stomach, and uterus, and different internal organs. They also have targeted glands and adipose tissue. Okay, so there's a variety of different organs that we're targeting in the autonomic nervous system. More differences between the somatic nervous system and the autonomic nervous system. Somatic nervous system originated from the central nervous system, more precisely in the gray matter of your spinal cord. Okay, so that's the place you're going to find the cell body of the motor neuron. And the motor neuron's axon is pretty long. It depends on which region you're going to innervate. It could be a very long axon. Normally, it's a single axon that is going to innervate your skeletal muscles. So that's always excitatory effect. And what is the neurotransmitter release in this system? Does anybody still remember that? Acetylcholine, very good. What kind of receptors involved in it? So nicotinic receptors. This is the binding of the acetylcholine directly opening up the channels, letting the sodium, potassiums to influx and efflux, right? So for the autonomic nervous system, it's different. Okay. So we have not just one motor neurons involved in each control. We have actually two motor neurons. The ones that originate from your central nervous systems is called preganglionic neurons. And the ones that are synapses with the preganglionic cells normally is originated outside of your central nervous system is called postganglionic neurons or postganglionic fibers. Okay, so postganglionic neurons directly innervating those internal organs like smooth muscles, cardiac muscles, glands, and other things. So we have two neurons in series, synapse with each other, and then make a control. Especially the postganglionic fibers, they can excite or inhibit their target organs. Okay, depends on the neurotransmitter they're releasing, depends on the receptors that's involved. So we're going to learn that. So this diagram is kind of summarizing what we have learned, and we can give you a little bit more precise image of how their synapses. So you can see that for the somatic nervous systems, you have those receptors that's coming, and the sensory neurons is located in the dorsal root ganglia, and they're going into the spinal cord synapses with your motor neurons, and the motor neurons leave the ventral root, or called the anterior root, and then innervating the muscle directly. And on the right side of the picture, we're showing the autonomic nervous system, which you still have the sensory neurons that the cell body located in the same dorsal root ganglia, and they are going to make synapses with the motor neurons. Oftentimes is in the lateral horn of this in the spinal cord, and these then coming out and leave from the ventral root just as a somatic nervous system. However, they are going to synapse. Okay, so see these ganglia outside of the central nervous system. Those are the nerve tissue outside of the central nervous system called ganglia, and they're going to make synapses to the second motor neurons in your autonomic nervous system, and then changing the internal organs function. Okay, so you can see that they're making synapses outside. Again, preganglionic neurons originates in central nervous system, and the postganglionic neurons originate in the ganglia. The ganglia, the location of the ganglia could be different from division to division. We were going to see in a second. Okay, we talked about there are two divisions of an autonomic nervous system, and there are the sympathetic division and the parasympathetic division. Some, if you're looking online, sometimes they call it, there's a third division, it's the enteric nervous system, which is precisely controlling your GI tract. We do not consider that in our course, so we're just going to differentiate it into two divisions here. Sympathetic, which is our fight or flight situation, which I just described to you. We all have this similar experience. Dr. Jangunas showed you a movie of these very innocent girls riding a bicycle. You guys remember that one? Okay, so when he was talking about the homeostasis, and he showed you that movie, and that movie should be me playing it today, and but he stole it, and that's showing you how you, after you see the movie, your your heart rate increase, your breathing changes, and all this was a fight or flight, very energetic response that is controlled by your sympathetic division. The parasympathetic division, we all know that if after your final you're going to lying at home, listen to the music, enjoying your hot cocoa, whatever, and that's the time we be able to rest and digest. Those are your parasympathetic tone will greatly enhance, and we are looking forward to that. And so you can see that normally most of our internal organs do receive innervation from both of these divisions, and at no time they will be only controlled by one division. They are always working together. The only difference is the tone will change. Okay, so there's always a basal tone, even for the parasympathetic division, even when during the fight or flight situation. So we have to know that the innervation of the target organ is normally dual innervation, and they always have some basal tone that never was shut down completely. Okay. So we're going to talk about the other anatomic structures of your first sympathetic nervous system. Okay. So the sympathetic nervous system is originated from the cerebral spinal cord between your T1 and L2. Okay, so very close to the thoracic trunk and very to the lumbar region. So very central part of your spinal cord. Okay, so the postganglionic neurons, where they find, okay, where the pre and the post synapses find, they could be found in 3 different regions as we listed here. So the primary places that you find the synapses are called the sympathetic chain ganglia. So we talked about the ganglia before. So what is the sympathetic chain ganglia? Is those ganglia find the chain, a series of ganglia very close to your spinal cord, actually very adjacent to the spinal cord on the 2 sides of your spinal cord. They also could be found in a collateral ganglia. We're going to see that. And the rest of them is found in the adrenal medulla, which is a very specialized and different synapses we're going to talk about today. So let's take a look at the chain ganglia. This is where we find the majority of the postsynaptic neurons, and they have one copy from each side of your spinal cord. So together they have two chains. They are very close to the spinal cord, and after that, the fibers, the neuron fibers of the postganglionic neurons, we're going to innervate your internal organs, especially close to the head and the heart and the lung. Okay, we're not talking too much about the visceral organs that are in the abdominal cavity, and we're going to see that in a second. So this is a sympathetic chain ganglia. Okay. So this chain, as you can see, this is your spinal cord, the big one, and close to it is your sympathetic chain ganglia. You have two copies on each side. Okay. So let's trace the sympathetic preganglionic neurons. So the sympathetic preganglionic neurons, the cell bodies originated in this spinal cord, the gray matter. Okay. So if we trace their axons, first they're coming out from the ventral root, and then they're going to possibly making synapses when they exit that level, the same level, and in the chain ganglia making a synapses with the postganglionic neuron. Okay, so this part is a little bit dry, but I'm going to show you why this is important. Okay, some of these neurons do not make connections, synapses, right at the exit level. They actually will travel through and making connections, maybe ascending or descending, and making connections at a different level, another level in the chain ganglia. Okay, so that means what is that important? So that means that any given region of your preganglionic neurons in your sympathetic nervous system could potentially innervating a variety of different organs. Okay, that is a very unique features found in the sympathetic nervous system, which is mass discharge. Okay, so oftentimes when you fight or flight, a lot of these reactions are happening at the same time. You sweat, your eyes open wide, the pupil opening wider, and you have your breathing heavier, and your skeletal muscles ready to action. So all these could be a very massive discharges coming from the sympathetic nervous system. So there's a lot of divergence happening from one given level of your sympathetic nervous system. Okay, so some of them never synapses in the chain ganglia. Actually, they are going to pass through this chain ganglia without synapse, and then they are going to synapse at a region that in front of your spinal cord. We call it a ganglia called a collateral ganglia. Okay, it's very important. Normally it's surrounding your aorta, that region. It's right in front of your aorta and right in front of your spinal cord. So this is called a collateral ganglia. And the collateral ganglia has one copy and not two, unlike the sympathetic chain ganglia. Okay, so this is showing you the collateral ganglia. And it depends on the places they're going to innervate. There are three divisions. Okay, so there are the celiac division, there are the superior mesentery and the inferior mesentery. So those are the ganglia innervating different portions of your body, more or less. And with the celiac, it's innervating the stomach and the duodenum, which is the first part of your small intestine. And you can also find the superior and the inferior mesentery ganglia innervating the rest of the abdominal and the pelvic cavity organs. Okay, so there's a lot of overlapping between these three divisions.